Let's talk about something pretty incredible. Technology that lets our source code literally draw a picture of itself, bridging that huge gap between raw text and truly interactive diagrams. If you're a developer, you've been here. We all have, staring at this wall of text, trying to build a mental map of a complex system. It can be a massive headache. But what if you didn't have to do that? I mean, what if the code could just explain itself by generating its own clear interactive diagrams? These are often called transient views, and they give you an instant visual roadmap of the whole system. So how in the world does this magic actually work? Well, it all starts with a really clever piece of foundational tech called the Language Server Protocol, or LSP for short. See, back in the day, if you had M different code editors and you wanted them to support N different programming languages, you had a huge problem. You had to write M times N plugins. It was just an absolute nightmare of duplicated effort. The LSP just brilliantly solves this. It creates the standard way for tools to talk to each other. It takes all the language smarts, like autocomplete and error checking, and puts them in one single reusable language server. Now, any editor can just connect to it. Problem solved. I love this analogy. Think of the LSP as a city's underground plumbing system. It's perfectly engineered to do one thing really, really well: deliver water, or in our case, text-based information, to every single house, which is like our code editors. But here's the thing. Code isn't just a stream of characters, right? It's all about structure, relationships, and logic. And honestly, those things are way easier to understand when you can see them visually. So that brings up the big question. How do you get that plumbing system, which was built for simple water, to start carrying something much more complex, like rich graphical diagrams? And the answer is a framework called Sprotty. To stick with our analogy, Sprotty is like a specialized filtration and distribution unit you attach to the city's plumbing. It's the thing that lets the system handle not just water, but also all this rich, complex graphical data. And here's the gist of how it works. Sprotty basically teaches the LSP some new tricks. It adds new, custom message types so the editor and the server can exchange what are called actions. These are just simple little JSON objects that carry commands like, "Hey, send me the diagram model," or "Just so you know, the user just zoomed in over here." It totally transforms a text-only protocol into a graphics-aware one. Okay, so now that we have all the pieces on the board, let's look at the key mechanisms that make this whole interaction between your code and the diagram feel so seamless and powerful. First off, everything follows this really predictable one-way street. When you click on the diagram, that fires off an action. That action zips over to the server, which figures out what you want, updates its model of the diagram, and then sends a completely new, updated diagram right back to your screen. It's a super clean, stable loop. Next up, and this is absolutely key for it to feel right, the system has to keep the diagram and your source code perfectly in sync, like all the time. This is done through something called tracing. Basically, every little piece of the diagram is tagged with a link back to the exact line of code it came from. This lets you do that magic cross-selection. You click a node in the diagram and boom, the code highlights. You click in the code and the diagram element lights up. It's a two-way street. Third, to keep the UI on your screen feeling super fast and snappy, all the heavy lifting gets pushed to the server. Complex stuff like recalculating the entire diagram layout when you expand a node. The server handles that, not your local machine. This keeps the client super lightweight and responsive. Okay, but what about really, really big systems? Trying to send a diagram for a massive project every single time would be unbelievably slow. That's where incremental updates are a total game changer. Instead of trying to send the entire blueprint for a million-line system at once, the client is smart. It only asks for the parts of the diagram you can actually see on your screen. This completely slashes those initial load times and makes it possible to work with huge systems. So what's the bottom line? What's the payoff for all this architectural fancy footwork? Let's talk about the real-world benefits and, the trade-offs that come with it. Well, the benefits are pretty huge. Your diagrams can never be out of date because the code itself is the one and only source of truth. They're always a live, perfect picture of your system. And because of all that server-side magic, the user experience stays incredibly fast and responsive. But, and there's always a but, right? This flexible, decoupled approach isn't free. It adds network communication to the mix, which naturally leads to a really important question about performance. And the raw data tells a very clear story here. Just look at these numbers. For a tiny model, the difference is, a second. But as you scale up to a system with over 35,000 lines of code, the client-server approach is over 7 times slower than a traditional all-in-one tool. That network latency really adds up. So it really comes down to a fundamental trade-off. You are absolutely sacrificing some raw speed, but what you get in return is just incredible flexibility. This is the kind of architecture that lets you run powerful ID-level tools right in a web browser, accessible from anywhere on pretty much any device. All of this really points to a fascinating future and leaves us with one last kind of provocative thought. We've just seen how we can create visuals from our code, but could we flip that around? This is the ultimate promise of this technology. The idea that you could directly manipulate a diagram to drag, drop, and connect things, and have those visual changes automatically write and refactor the actual source code. I mean, that's a future that could truly, fundamentally change how all of us build software.